Right, in this video, I'm going to provide the explanations for the homework questions from assignment 1B. Right, let's look at 4B. Right, you're asked to solve the equations. 3 bracket x plus 1 multiplied with x minus 1 equals to 7x. Right, so there are actually 3 linear factors on the left-hand side. Right, so if you don't have the number 3 there, then probably what you will just do will be multiply these two linear factors, right, using the distributive law. But what happens if you have a 3 in front? So how do you go about doing it? Right, don't worry. We can still apply this distributive law, but we're going to multiply 3, distribute 3 to your linear factor x plus 1 first. Right, then you will get, when you expand 3 bracket x plus 1, you will get 3x plus 3. And then the next step is you expand your 3x plus 3, distribute it to your x minus 1. Okay, and then the next step is just keep expanding. Right, then simplify everything. As in, like, make the right hand side equals to 0. Right, write down the values for a, b, and c. Compare it with the quadratic equation, which is your ax squared plus bx plus c equals to 0. Right, so you can see that a is 3, b is negative 7, c is negative 3. Write down the formula and do the substitution correctly. Use a calculator to help you, and you should get two answers, negative 0.3699. Now, in this question, you are not told about the degree of accuracy. So if you're not told about the degree of accuracy, usually we will express our answer to 3 significant figure. Right. And then the second answer will be 2.703. Expressed to 3 significant figure will be 2.70. Right. So to summarize what we have just done, if you are given 3 factors, okay, what we're going to do is that you work out these two guys first. All right. And after you work out these two guys, then using that answer for these two guys, right, you work out, you apply distributive law with the last linear factor. All right, let's look at another questions. This one is slightly harder because you're actually given a algebraic fractions, okay, instead of the algebraic expression, right? But not to worry. Okay, to solve any problem sum, right, you just look at it and ask yourself which portion, which small parts that you can manage, and you just go ahead and manage the part. So if you were to examine the algebraic fractions on the left hand side, right, I'm sure you can expand x bracket x minus 3. You can also expand the denominator, right? So this is exactly what we're going to do. And what I have done here, I've applied this algebraic identity. All right, to expand it, and then that simplified it. Okay, the next step is we're going to do a shortcut, and that is I'm just going to take 5 multiply with x squared minus 3x, and then take 3 multiply with x squared plus 2x plus 1. Of course, the equal sign remain the same. You just carry on with the equal sign in the middle. Right, so the next thing is expansion. You can expand what you see on the left, and you can expand what you see on the right. And then we can just bring every terms to the left hand side, simplify it to get a quadratic equation. Again, compare it with your general form of a quadratic equation, which is ax squared plus bx plus c equals to 0. write down the values for A, B, and C, write down the quadratic formula, do the correct substitution, use the calculator to help you, and you should get answer 10.6 or negative 0.141. Alright, in this question again, you are not told the degree of accuracy, so usually we would express our answer to 3 significant figures. Okay, let's look at another question here. So you're given two fractions on the left hand side, right? So what we're going to do is we're going to combine these two algebraic fractions into one. So the common denominator will be x times bracket x minus 1. Right, so what do we need to do? We will have to multiply the first fractions. Okay, look at what you have here. The first fraction here, you have 4 over x. Then what should I do to get denominator x bracket x minus 1? Yes, you need to multiply it with x minus 1, right? But you can't just multiply it with x minus 1. It means you're changing the question, right? So you have to also do it at the numerator. So this is what we're going to do. So for the other one, the other guy, you need to multiply with x. Right, because what you have here is only x minus 1. So in order to get this, you will have to multiply with the x at the denominator, also at the numerator. So this is what happened. And then the next thing is write 9 as a fraction, 9 over 1. Alright, what's the next step? Next step is to expand the numerator of the left hand side. Also, expand the denominator, that will give you x squared minus x. Alright, so what do we do again? Simplify further. And then you have one fraction on the left equals to another fraction on the right. A single fraction, okay? This is a single fraction, and this is also just an integer, right? So now you can do a cross multiply. Alright, and then you simplify it. Okay, wait, I need to erase off this, because later on I'm going to show you the cross method for factorization. Alright, so we bring everything to the left hand side, simplify it to get a quadratic equation. And in this case here, there's no need to use quadratic formula. If you want to use it, also go ahead. Another way of solving quadratic equation is using factorization. Right, which is what I'm going to show you. Right, so you will have two linear factors that are the same, which is 3x minus 2. Right, so you can apply your AB product rule. Right, you just let 3x minus 2 equals to 0. So you will get here x equals to 2/3. Okay. Right, so far we have managed to solve some rather basic questions. Now let's do more additional practice. Let's look at some challenging questions. So if you look at what we have on the screen, the algebraic fractions looks kind of more complicated, especially for this guy here. Right, so we need to combine these two fractions into one single fractions. So some of you may be tempted to do it this way. Right, so what happened is that if you're just going to combine the denominator, combine both denominators, just multiply them together, it's not going to be an effective way of doing it, because the denominator is going to be very complicated. Right, so what we should be doing is to factorize x squared minus 5x plus 6. X squared minus 5x plus 6 is a quadratic expression, and we can factorize it into two linear factors, x minus 3 and x minus 2. Right, so the way to go about solving this kind of question is do not jump into the boat too fast. Right, try to see if you can actually factorize any of the expression given. Right, so here we can actually factorize x squared minus 5x plus 6 into x minus 3 and x minus 2. Alright, so now we can clearly see that the common denominator will be just x minus 3 and x minus 2. Right, so we can, as what I've explained earlier on, alright, if you look at your first algebraic fractions, look at the first, look at this denominator, what we are lacking is x minus 2. So I need to multiply it with x minus 2 at the denominator, also at the numerator. So that explains how I get this part here. Multiplying 3 with x minus 2. And if you look at the second fractions, I've already got x minus 3 and x minus 2 as the denominator. So basically, there's no need to multiply x plus 1. We just need to multiply x plus 1 with 1. Alright, and then we're going to simplify. Again, simplify the numerator, simplify the denominator. Right, and then do a cross multiply, which we have already done it several times. Alright, and then express it as a quadratic equation. And we'll continue in the next slide. Alright, so from the earlier slides, we've ended up getting a quadratic equation which is x squared minus 9x plus 11 equals to 0. So we compare it with the general form, which is ax squared plus bx plus c equals to 0. Write down the values for a, b, and c. As usual, write down the quadratic formula. As usual, do the substitution. Alright, important thing is that you have a negative value for b. Right, so you need to bracket it. That is something very important here and here. Alright, the next thing is that you can just use your calculator to help you evaluate the expression. And you'll get 7.54 or 1.46. Right, let's look at another question. This one is rather challenging. Right, so first thing first, we need to understand that bracket n minus 2 to the power of 2 is actually just is a perfect square. So if you were to break it down, it's n minus 2 times n minus 2. Okay, or if you have bracket a minus b close bracket to the power of 2, it means it's just a minus b times another a minus b. Right, so the next thing is that take note that the common denominator now will be just n minus 2 multiplied with n minus 2. Right, so we need to multiply your first algebraic fractions with another n minus 2. And then, of course, the second one we don't have to multiply, just have to multiply with 1 because at the denominator you already have n minus 2 times n minus 2. Now, so the second recap is that you can actually write negative 2 over 1. All these three stuff here, they're equivalent to one another. So this is what we're going to do next. We're going to put the negative sign at the numerator. That means we're going to write it as negative 2 over 1. Now, the third recap is the expansions of n minus 2 times n minus 2. Right, we use distributive law here. And then you end up getting n squared minus 4n plus 4. Right. And then the next thing is that we're just going to do a cross multiplication. Right, before we do a cross multiplications, we can just simplify this term here. And then we do a cross multiplications. Right. So as what we have done earlier on, we do some simplifications and then end up getting a quadratic equations on the left hand side. Compare it with the general form of your quadratic formula. Write down the values of a, b, and c. Write down the quadratic formula. Use a calculator to help you. And then you should get the answer for n. right, we're actually solving for n and not x. So be very careful what you're solving for. So since you're solving for n, make sure that this is n equals, and then write down the quadratic formula. So the answers you should be getting is 2.28 or 0.219. Alright, so let's come to the last question. Now in this question here, you're still dealing with two algebraic fractions on the left hand side, except now that you have to apply the algebraic identity here. So earlier on, what we are given is n minus 1 squared, perfect square, which is equals to n minus 1 times n minus 1. So now what we're dealing with is we need to apply the algebraic identity. So let's do some recap here. Okay, so recall that 1 minus 4t squared, you can actually write 1 as 1 squared because 1 times 1 is 1. And 4t squared, right, you can actually write it as 2 squared times t squared, which is the same as bracket 2t cross bracket squared. Okay, that will gives you 4t squared. And this will remind you of your algebraic identity, which is your a squared minus b squared. That gives you a minus b multiplied with a plus b. So in this case here, your 1 is your actually the value that you can substitute for a in the algebraic identity, and you can substitute 2t as the value for b in the algebraic identity. So you end up getting 1 minus 2t and 1 plus 2t. Right. So in this case here, then we observe that the common denominator will be 1 minus 2t and 1 plus 2t. Right. So once we get the common denominator, right, the rest of it is pretty simple. We just take 6 here. Alright, 6 here multiply with 1 plus 2t. Okay, and then 3t here multiply with 1 minus, oh, we don't have to, because the denominator is already 1 minus 2t and 1 plus 2t, so you just have to multiply with 1. And then the next step is just to simplify your numerator. Okay, put back 1 minus 4t squared for your denominator, because we're going to do a cross multiplication. Right, and you end up getting a quadratic equations again, simplify it. Right, and you compare it with your quadratic equation, which is your ax squared plus bx plus c equals to 0. Okay, write down the values for a, b, and c. Substitute into your quadratic formula. Right, in this case here, be careful. What you're solving is for the values, what you're solving for t and not for x. Previously, we're solving for n. So your quadratic formula is n equals to blah, blah, blah. Here, it will be t equals to your quadratic formula, right? So do the substitution. So the values for t will be negative 0.370 or negative 3.38.